I'm moving on here to the next slide, which is actually a continuation of the same slide, but it's on a different scale, and it'd be hard to see them both on the same graph. So it's the same thing here. We have two more apps here, Milk and Paratech, and by the time you get to Paratech's communication, you're seeing on Amazon EC2 about a 50x greater performance difference. We saw better performance with EC2, the cloud computing instances, which in this graph, unfortunately, has been labeled differently. But what we realized was scientific applications with minimal communication were best suited for these cloud environments in general. In the current time, the technology changes happen pretty quickly in this space, so this is likely to change as the hypervisor and networking gets better within the VMs. So then we did a follow-on study which tried to tease apart what happened at scale and where the principal decrease was happening. So we did this study mostly with Paratech and Milk, and I haven't included the graphs of Paratech and Milk here, mostly because I wanted to focus on sort of what were the reasons which I think are important to understand. So we ran Paratech and Milk, and we ran the HPCC benchmark, which is the benchmark that's commonly used on the HPC machines to understand different characteristics of the system, including HPL, which is part of the top 500, which is used to characterize the top 500. So what you're seeing here is in the next two graphs, I'm going to show how the bandwidth does for different configurations. So we had this is all run except Amazon CC, which is marked here with the triangles and the, I guess, maroon line. Everything else happened on the Magellan testbed, just with different configurations. And first we ran InfiniBand, then we ran the TCP over InfiniBand. That's used the InfiniBand fabric, but used the TCP protocol in the InfiniBand fabric. Then we did a study where we used a 10 gig TCP over Ethernet, and then we had a bunch of different virtual machines, configurations and stuff. So what you end up seeing here is InfiniBand. Here, higher is better because we're looking at bandwidth, and InfiniBand does the best. And the difference between InfiniBand and the next line, which is the red dotted line, is where the change actually happens in terms of bandwidth. So the principal decrease in bandwidth occurs when you switch to TCP over IB. So it's the difference in the protocol that made that huge difference. So you started out at 32 cores at about 2x, and then went up to at 1024 about 5x. So that's an important result. And ping-pong bandwidth is just essentially one core pinging one other core. So there's three benchmarks that are there are three sort of things that are measured as part of the HPCC bandwidth measurements. Ping pong is one, natural ring, where each one pings the next one on its circle, and the random ring, where there's the maximum contention. So if you look at this graph here, you see again InfiniBand does the best. You see that as there's more contention, you see a decrease in the bandwidth even provided with InfiniBand. When the increase in contention also means increase in the number of cores here. And the decrease because of TCP over IB is a little less, but you see that the Ethernet connections basically are unable to cope with significant amounts of network contention. You see that they start they're really low down comparatively. So that's the random ring bandwidth. So next we'll switch to the latency. And I hate doing this in graphs where higher is better and lower is better and switching between them, which is why I have that little sign on my graph which shows you what is better here. So when you're looking at the latency, to some extent you see a reverse of what we were seeing with bandwidth in terms of how the progression is. And InfiniBand has sort of the best latency. It sort of stays with the ping pong latency, it stays mostly flat. And the principal increase in latency occurs for TCP over IB even at mid-range concurrency. So you start seeing that by the time you hit 128 to 56, the TCP over IB starts sort of declining. The latency starts increasing, which means the performance decreasing fairly rapidly over here. And most of the lines sort of mirror that trend as you go further in with different this. One thing I forgot to mention here was one of the reasons we picked 10 gig was 10 gig was the closest that you will see to what's available on Amazon CC. Amazon CC is supposed to have 10 gig. So having a 10 gig on our system helped us sort of have a similar environment here. Our 10 gig VMs perform worse than Amazon's this, but our hypervisors have not been tuned. They don't have any special optimizations other than what comes out of the box. So the next chart here is showing the random ring latency. So there's a lot of contention here. And you see that latency is actually affected by a larger amount than the bandwidth as you go up. So here, the 10 gig VM almost shows a 6x difference, which makes it, you see that latency is really affected in the virtualized environment. And that's definitely one of the major reasons that explains the performance that we were seeing with applications. The latency does take a major hit.